Inequalities in slope-intercept form today. So the first thing I want you to do is go to your packet, and I want you to go to lesson 1. And now, before you reach here, remember there's a section for your vocabulary, words that you may see in the video that you want to fill in here. And we're going to go to lesson 1, video summary. So I gave you 2 graphs here, which you can use to copy 2 examples from the video that you think may help you, and you can use as guides, models, or examples. Please write down important ideas in this section, and then on this section you can write questions or comments that you can bring up when I see you in class. Okay, let's go to the lesson. So the first thing I want to do is just go over what we know about equations and inequalities and how they are a little bit different when we represent their solution. Okay, so solving equations, well, let's solve this. So using inverse operations, -6 on this side, -6 on that side, and we get that x has to be equal to 4. So x equals to 4 and nothing else but 4. So the solution to this equation is just 4. And we can test it out. Sorry, we can check. Right, so instead of x, let me put 4. I get 4 plus 6 equals 10. 4 plus 6 is 10, which equals a 10 on the other side. So the 2 expressions are equal to each other. And there's nothing else in this world except 4 that will make that equation true. So on a number line, how would I represent that solution? On a number line, I would do something like this. So I would go on top of 4, a little circle, and I'm going to shade 4 to say that 4 is the solution and nothing else but 4. That's it. 5 doesn't work, 4.1 doesn't work, 3.99 doesn't work, 2, -1, nothing else except 4 works. So this would be the representation on a number line. Well, look at the inequality. It's a little bit different. Again, inverse operation, -6, -6, and we get that x is greater or equal to 4. Now, look what it says. It says here that x can be equal to 4 or greater than 4. So there's more than one possibility. So on the number line, how do I represent that? Well, it can be equal to 4, so I'm going to shade 4, so that tells me that 4 is part of the solution. And x can be anything greater than 4. So, and to show greater than 4, I'm going to draw a line pointing to anything that's greater than 4. So anything on this side of the circle of 4 is part of the solution. And you can always test it out. So pick 4. If you pick 4, you get 4 plus 6 is greater or equal to 10. Does that make that inequality true? It does. If you pick, I don't know, 28, add that to 6. Is that greater or equal to 10? Yes, it is. And where's 28? 28's to the right. It's here, right? It's 28. There's what 28. And numbers to the left, they won't work. So that's the differences, right? There's more than one solution with inequality, whereas equation, there's one solution. Yes, except when the expression on the left and the expression on the right are exactly the same, and you can have infinite number of solutions, but that's besides the point here. So, and then we're going to have to represent this, right? We're going to show this on a graph with a couple of changes, okay? So, things that we have to know for today. When it's less than or greater than, right? Instead of on the number line, we left the circle unshaded, right? But on a graph that we're about to do, how do we represent that? We're going to use not a solid line, we're going to use dashed line because numbers on the line are not part of the solution. If it's less than or equal to and greater than or equal to, then we're going to use a solid line. So that takes care of this, and that, right? That we just did. That's what that would be on a coordinate plane. Now, how about pointing the arrow to the left or pointing the arrow to the right of the circle? Well, on a graph, we're going to shade a region. So if that's the graph and this is the line, we're going to shade a particular region to show you that that's to the left or to the right. Sorry, to the right or to the left of the circle. That's what that would be. Well, I think it's better if I just showed you. Let's look at the first example. And we have y equals 2x plus 1, which is written in our slope-intercept form. Where b is the y-intercept, so right off the bat, I'm going to go to 1, y equals 1, and draw my first point. and my slope is 2, positive 2, which means that from left to right, it's going to go up. So the change in y is 2, and the change in x is 1. So between y values, let's count 2, and between x values, let's count 1. So 2 up, 1 to the right. So that gives us the points on the line that we're about to draw, and in this case, that's what it looks like. And the solution to this equation, y equals 2x plus 1, is any point on that line. So let me just pick a random point. Pick this point right here, which is 3, 7. So if I plug in x value of 3 and y value of 7 in this equation, will it make it true? Well, let's check. 7 equals 2 times 3, which is 6, plus 1, and you notice that it is true. So, and likewise, if I pick the number that's not on the line, and let's just do this quickly, 5 and 4, you'll see that it does not make that equation true. So we get 4 equals 2 times 5 plus 1. 4 equals 2 times 5 is 10 plus 1, which is 11, and definitely not true. So only points on the line make it true. Okay. How does this transfer to when we're doing inequalities? Well, let's do this inequality, which is the same exact numbers. So I'm just going to quickly plot the points, same slope, right? So the first thing from the previous example, we proved that points on the line make that equation true, and then therefore will make this inequality true. So if it's a greater than or less than symbol, right? What kind of line are we going to use? We're going to use a solid line right here. That's a solid line, right? So we already know that points on that line made that equation true. So it's going to make this inequality true as well. And we use the point 37, so I'm just going to use it again. So we get 7 is greater or equal to 2 times 3 plus 1, and notice that 7 is greater or equal to 7. It's not greater, but it's definitely equal to 7. So the point 37, this point 37 works. So we know points on the line will make this inequality true. That's one. Now you got to tell me, hey, is it going to be, do I point that arrow, remember how we did arrow to the left of the circle or to the right of the circle? Well, is it going to be to the right of the line or to the left of the line? Which one is it going to be? And to do that, we're going to select a point. I want you to pick the easiest point you can. And the easiest point, by the way, for me at least, is this point right here, 0, 0. So 0, 0 is to the right of the purple line, right? Below the purple line. So if I plug 0, 0 in here, and it makes that inequality true, then I'm going to shade this region here, because that's going to tell me that every point on this region makes that inequality true. If it doesn't work, then I'm going to shade the opposite side. Okay. So let's try point 0, 0. Let's see if it works. So we get 0 greater or equal to 2 times 0 plus 1, and 0 greater or equal to 1, because 2 times 0 is 0, 0 plus 1 is 1. Is it true? Well, 0 is definitely not greater than 1. So the point 0, 0 failed. And if it failed, every point on the same side that 0, 0 is also going to fail. So we want to shade the other side. And the way to shade it is to draw perpendicular lines, nice and easy. Perpendicular lines to the purple line that we just created, like this. And this says, and I'll put a big S for solution, that every point above the purple line makes this inequality true. And we're going to pick one. Of course, we're going to pick one just to see if that's true. And let's just pick one. Let's pick this guy right here, -2 and 5. Well, if I plug in -2 and 5, it's going to work. 2 times -2 plus 1. 5 is greater. 2 times -2 is -4. -4 plus 1 is -3. Is that true? Yes, it is. So that point worked, and so will every point above the purple line. So, two things. One, first of all, look at the inequality sign. If it's a symbol that has an equal sign at the bottom, greater than or equal to or less than equal to, please use a solid line. Once that's done, you need to take a point, pick a point above the line or below the line, and test it out. If it works, shade that same side. If it doesn't work, then you're going to shade the opposite side. That's literally it. Let's do one more. Let's do this one. So let's start with the y-intercept. The y-intercept is 4. Our slope, we're changing y, changing x, it's going to be -3 over 1, right? So between x values, y values, you're going to count 3, and between x values, you're going to count 1, and it's a negative slope. So it means you're going to go, it's going to look like that. So let's count 3 on the y. 1, 2, 3, and we're going to go right 1. 1, 2, 3, right 1. 1, 2, 3, right 1. 1, 2, 3, and then left 1. And this time around, look at your inequality sign. Doesn't have the equal sign, so we're going to use a dashed line. Why are we using a dashed line? Because if I took a point on the line, it would not make that inequality true. Okay? And just because this is our first time doing this, I'm going to prove that. So let's pick this point right here. Actually, let's pick an easy point. 1 and 1. 1 and 1 is on the line, and it's not going to work. So we're going to go 1 less than -3 times 1 plus 4. 1 is less than, that's a times by the way, -3 times 1 is -3 plus 4 is 1. Is 1 less than 1? No. So it failed. Right? So point on the line failed. That means all the other points on the line fail. Okay. Now we need to either shade below the line or above the line. And the way we do that is, like I said before, we pick a test point. So let's pick the easiest one. Pick 0, 0. It's below the line. So if 0, 0 works, everything below the line will also work. So let's plug it in. 0 less than -3 times 0 plus 4. 0 is less than -3 times 0 is 0, plus 4 is just 4. Is 0 less than 4? Yes, it is. So that's telling you that because 0, 0 worked, every point on the same side of 0, 0 will also work. So you can pick any point, right, here, and it will make your inequality true. So the solution is any point in there. And then on a test or quiz, they probably ask you to pick a point and just to double check. So let's pick, I don't know, this random point right here. What is that? -3 and +3. So I'll do a little check just to double check. And we're going to use the point -3, 3. So we get 3 less than -3 times -3 plus 4. 3 is less than -3 times -3 is +9. And 9 plus 4 is 13. Is 3 less than 13? Yes, it is. So see how -3 and 3 worked. Everything else will also work as well. So let's summarize what we've done so far. So how do we determine if a solid or dashed line is used? So important, if it's less than or greater than without the equal sign at the bottom, I want you to use a dashed line. If you see a less than or equal to or greater than or equal to, I'd like you to use a solid line. Okay? And then you're going to use test points to determine the solution area. So I'm going to draw something like this. So let's say this was your line. You would take a point, any random point, above the line or below the line. It's up to you. Pick a point. If that point works, then you shade the side where that point is, which is under the line. If it doesn't work, then you're going to shade the side opposite where that point is, which is the other side. Okay. There are a couple of special cases here. Okay, so let's go back to this. Let's see if you remember. This says y is greater than 2. Well, y is greater than 2. Before we even do that, I want you to graph y equals 2. Y equals 2 is a horizontal line, right, that goes across 2, that passes through 2. So let's, what would that line be? That line would be this guy right here. I'm going to draw it first, this line. But because this symbol here, this inequality sign, is greater than, right, without the equal sign, we're not going to use a solid line, but rather we're going to use a dashed line. So go over here. Right. So now we want the side where all the y values are greater than 2. Do you think it's going to be up here or down here? Well, I can't pick a test point. Pick pick a point. I don't know. Let's stick to 0, 0. Let's pick this point 0, 0. 0, 0, this is my x value, this is my y value. So let's take the inequality. Y is greater than 2. Let's substitute it with 0. And 0 is greater than 2. Is 0 greater than 2? No, it's not. So we don't want the side in which the test point that we just used, 0, 0 is. We don't want this side of the world, right? We want the other side. So we want, we want this side over here. So all these points, right, above the line have a y value greater than 2. Let's just pick one random one right here. That point is -6, 4. And let's plug it in into the inequality. Y equals greater than 2. This is my x and this is my y. So the y value is 4, and you can tell that 4 is greater than 2, and that's true. So that makes the shaded region above the line the solution to this particular inequality. Let's look at this one. Well, you know it's going to be, first of all, look at the inequality side. You're going to know it's going to be a solid line. And we want a solid line, okay? But before you look at x less or equal to -3, think of it as this. Well, locate that. Well, that's going to be a vertical line, first of all, right? So remember, and it's a vertical line that goes through -3. So let's see where that is. -3 is right here. And it's going to be a solid line because it's a less than or equal sign. Right? So now we want all the points, besides the ones that are on the line, that are going to be less or equal to -3. Well, where are the values that are less or equal, x values that are less or equal to 3? Well, obviously, well, I don't know if it's obvious, but it's to the left of the line, right? Because you see x here is -4, x here is -5, -6, and all those x values are less than -3. So you want to shade the values, the area, the region, to the left of the line. Now, you could have always picked a point. I don't know, pick a point here. Let's, again, pick 0, 0. And if you pick 0, 0 as your test point, this is your x value, this is your y value, you would have found that substituting x with 0, you would get 0 is less than -3. Is 0 less than -3? No, it's not. So which side is 0, 0? 0, 0 is to the right of the line. So we don't want this to the side that's the right of the line. We want the side to the left of the line. And that's where the solution is. So, and you can, again, pick any point. And I'm just going to pick a point right here. What's that point? -7. So if you tried the point -7 and -4 and test it out to see if it would make this particular inequality true, well, x is less than -3. Let's replace x with -7. Is -7 less than -3? Yes, it is. So again, prove that this side of the line is the area or where the points that make the solution, that make the inequality true, are located. Okay, so that's it.